In this video, we are going to talk about Autonics CT series, which is a programmable digital counter as well as timer. We are going to look at the counter functions of this product. So this product features with different options of communication as well as number of outputs. So it is also available with RS-485 communication. There are various functions of output which are available inside, as well as the various types of timer combinations are also available inside. The counter is available with 6-digit model as well as the 4-digit model, and it also functions and it also has batch counting function available with it. So this is how the ordering information for this counter is available. You can select either it with 4-digit or 6-digit with different sizes. It's available with either one output or two output or a without output model, which is only an indicator model, and the power supply selection as well as the communication option. So this is the wiring diagrams which are available with respect to its single stage output or two-stage output. We are having over here a model which is having one stage output and it is of M size. So we are having a model with us which is CT6M-1P. So this model is for a 230 volts supply. So the supply can be provided 230 volts at pin number 6 and 7. And it is having option to connect the pulse input at pin number 8, 9. 10, 11 are for sensor supply. So the module also gives a 12 volts supply, 12 volts DC supply with 100 milliamps sourcing output. So pin number 10 is 12 volts, 11 is 0 volts. If you are using an encoder, you can connect the A pulse of encoder to pin number 8, B pulse of encoder to pin number 9, and the encoder supply, if the encoder is able to power up at 12 volts, you can directly connect pin number 10 to plus V of encoder and 11, pin number 11 to 0 volts of the encoder. In our case, we are using an Autonics encoder E50S8 360 3N24, which is an 24 volt DC encoder. So this encoder works with power supply from 12 to 24 volts DC, and it is having PPR, pulses per revolution, of 360, and it is with NPN output. So we have connected its output A and B to pin number 8 and 9. Okay. Pin number 14 is a batch reset input. So we have connected CR30-15DN. This is a capacitive sensor from Autonics to demonstrate the batch counting option also. So batch reset input we have given of this capacitive sensor at pin number 14. So we also have the output, single stage output at pin number 17, and batch output is available at pin number 18. Let's see the basic functions of how this encoder input can be configured to measure the encoder pulses inside this counter. So we are going to look at the configuration of this counter with an incremental encoder of 360 PPR. So as per the wiring diagram shown, we have wired up the encoder over here, and we have not done any kind of setting yet inside the counter. Okay, and if I rotate the encoder, you can see it is counting the pulses. Okay, now you can see the count value right now is 14, and if I try to rotate it complete 360 degree, okay, the PPR, I have just rotated the encoder shaft by 360 degree. Okay, and the PPR value is 360, so I should have seen 360 count value over here when it rotates completely 360. Because the PPR is 360, it should give me for the 0 to 360 degrees 360 pulses. but the counter is not able to count those much pulses over here. Okay, I can show you it again. If I reset the count value, and you can see the mark over here. I am rotating this completely 0 to 360. And you can see, yeah, it is not able to count complete 360. That is because when I'm rotating the encoder shaft, the pulses are received in a very high speed that the counter is not able to read it. So there is a setting called as CPS inside the counters. Okay, cycles per second, that we need to set it as per our application. So since I'm rotating it, the pulses are coming very fast. Okay, I need to increase that CPS value inside. Okay, so if I just go inside the counter programming mode, so to go inside the configuration parameters, you can keep this MD key pressed and it will enter the programming menu. The first menu is input type, the input function that we want to configure. There are different functions. We'll see one by one what are those. Then this is CPS. Right now CPS is 30, so it can count maximum 30 cycles per second. But somehow when I was rotating the encoder, the pulses were going beyond this rate. Okay, so I should increase this rate. So say I'll keep this 1000 pulses per second. Let's see, after keeping this, it should read. If it is not able to read with this, you can increase it further to 5000 and max to 10,000. Okay, so I'll check with 1000 pulses. Okay, then there are a few other parameters like output type, function that you want to set, what type of signal input you want to set. So right now my encoder is NPN type. That's why I have selected here the NPN type output. NPN type in encoder input signal. So based on your encoder, you should select this input over here. Okay, so this is reset time, decimal point, scaling value, data retention, lock. Okay, and whether you want to use this as a counter or a timer. Okay, so let's see. I have changed the CPS value to 1000, and if we are able to read complete 360-degree count of the PPR that the encoder is supporting, I'll again keep pressed MD key so that I'll go back to run mode. Now we can see the count is 0 and also the shaft position. I will rotate it complete 360-degree. Okay, so after rotating it exact complete 360, I'm able to read the count value of my encoder now. Okay, then let's see the type of modes that we have here. If I keep pressed MD key and if we go in input, so what type of input modes are available? There are different modes which are available over here: UDC, UD, UDA, B and C. So out of which UDC mode is there. Okay, so let's go to the PDF of CT6M and let's see the data sheet, what these modes are. So if we go to the data sheet, we can see here we have up counting mode where input A is counted if input B is low, or input B is counted if input A is low. Or there is up counting mode 1 where input A is counted when input B is not present, not counting. Or up counting 2 mode, okay, where input A is counted but in falling edge. So these are the different modes, whether you want to do down counting, okay, or there is an up and down mode, okay, or there is an up and down mode B, and there is up and down mode C. So in our case, if you want to precisely count the number of pulses when the encoder is moving ahead, and as well as decrement the pulses when the encoder is moving back, okay, you can use up and down C mode. Okay, so it can do up counting and down counting, and it can also detect the phase difference present between pulse A and pulse B. Okay, let's see the same thing in our example over here in our demo setup. So in our demo setup, if we look, if I increment the pulses are increasing. Likewise, if I rotate it other way, the same pulses are decreasing. So this mode, which is happening right now, detecting the phase difference as well as counting up and counting down as per my shaft rotation, is UDC mode. If I go to MD, in the parameter, you can see this is our UDC mode. Okay, now let's take an example. If you want to count to a particular set point, and after reaching that set point, if you want to turn on an output for a certain period of time, okay, so you can add that set point over here in the preset value. Okay, so to add set point, you can use the arrow keys. Let's say, for example, we will add the set point as 10. Okay, and with by default setting, let's see what happens. So if I count 1, 2, 3, 4, 5, 6, 7, okay, you can see output turned on and output is continuously on, and my count value is also increasing above 10. If I want to reuse the counter from starting 0 and turn off the output, I need to press the reset button. And again, I can do the counting. Once it reaches 10, output will turn on and the count can increase, but my output still remains on. If I want to reuse it, I need to press the reset button. Many times there is an application where user wants to count to a certain value, say till this set point 10. After reaching 10, user wants to automatically reset as well as keep the output on for a certain period of time. For such an application, let's see which type of output mode is applicable. Now this is related with output, so it will be related with the output mode parameter. Once we go into the PDF, let's see. These are type of output operations which are available. So in this output operations, right now, the output mode is F mode by default, which keeps on increasing the value till it reaches the end of the count value. In our case, it is 6 digits, so end of the count value is 999999. Until the time it will keep the output on until reset button is pressed. But let's say if we consider an application in which we want to keep the output on for a certain period of time after reaching a set value. In that case, we can move forward with mode C, in which you can reach to a certain set point, after which the output will turn on. Once the output turns on, you can use one shot output time value to keep the output on for a certain period of time. Let's see the same in the demonstration now. So here I'm moving back inside the configuration parameters, pressing MD key for certain time. This is my input type mode, up and down counting, cycle per second parameter. This is my type of output I want. So let's change the type of output mode to C, what we saw right now. And this is the output time that you can set. Okay, this is in milliseconds. So 10 milliseconds, 50 milliseconds, 100, 200, 500, 1 second, 2 seconds, 5 seconds. Let's say, for example, we'll consider 5 seconds so that we can see the time properly. After doing the settings, let's come out of this mode. Okay, and we can see our output value is 0. Set point is 10. I'm increasing the output now. See, once it reaches 10, the output is on for certain time and output turned off after 5 seconds. Also, the count value got resetted. So you can see if we count till 10, output resets as well as output keeps on for 5 seconds. In this same example, let's see how batch counting will work now.